6, applications of integration. The definite integral is used to compute area between curves and volumes of solid and the work done by varying force. This is accomplished by concept of Riemann sum. And also we will use an integral and evaluate the integral using the fundamental theorem of calculus. Okay. Section 6.1, area between curves. In this section, we study how to find the area of a region bounded by a single curve and in general bounded by two or more curves, like this. Okay. Let S be the region that lie between the two given graph y is equal to f of x and y is equal to g of x, like this. Let this be the region. Then, between the vertical lines x is equal to a and x is equal to b, as you see in figure 1. Okay, then, how you find this area? How you did find it? And you divided S into n vertical strips of equal width, and then approximate the I strip by the rectangle with the base delta x, like this. Then the height is given like this. So the area of the ice rectangle can be found as this height times base delta x. This height times delta x, like you see in the next figure. Then the area S is approximated equal to the Riemann sum, like this. Riemann sum, like this. This area and with the summation of this area. And then what this means is like this. This area can be found the summation of these rectangles. Okay. If we send n to infinity, then this delta x approaches to 0, and the area A of S is the limiting value of the sum of the areas of the approximating rectangles, like this. The area that you are looking for, can be obtained in this way by using the Riemann sum. Okay. Suppose f and g are continuous and positive functions with this, like you see here. Then, and then area A of the region bounded by the curves on AB, like this. Then the area A is the area under y is equal to f of x minus the area under y is equal to g of x, which can be obtained in this way. Okay. This in general, as you see in here. And in general, if f and g are continuous function with just f of x is greater than or equal to g of x, like you see here on the interval a and b, then the area A of the region bounded by the curve on AB and the lines x is equal to a and x is equal to b is this. So this area A can be found the integral from a to b f of x dx minus integral f of b g of x dx, which can be written in this way. Okay. Here is the very simple example. Determine the area of the region bounded above by y is equal to e to the x, bounded below by y is equal to 1/2 x, and bounded on the side by x is equal to 0 and x is equal to 1. Then we draw we want to find this area. So like what we did, see. This area can be found the integral from 0 to 1. This x e to the x minus x over 2, which is this. which can be obtained in this way, which gives us E minus 5/4, which can be simulated copy. And we can actually this shows exactly what we want here, and also this area can be found by integral e to the x minus x/2 from 0 to 1, which is e minus 5/4, like this. Okay. Okay. So, next example shows calculate the area of the region enclosed by y is equal to x and y is equal to x square here. So in this case, we don't know which graph is on the top and which one on the bottom, and where those two graphs meet. So the best way is to draw those two graphs and find the intersecting point, and then we just do integrate from 0 to 1 x minus x square. So integral from 0 to 1 x minus x square dx. So all this can be done if we can draw the proper graph without much difficulty. Okay. But in general, for the two functions f of x and g of x, the value of those functions can be bigger in some area, some interval, and the smaller in the other intervals, like what you see here. Even though you have a function f of x like this, the function g of x like this, then you have three different areas, intervals, where f is over g, and g is over f, and f is g over x, like f like this. So in this case, what you're supposed to do is find the area separately with the integral from on that interval from the upper function minus lower function, like this. So you have to find these three areas differently and have to add to get the proper area like this. So the simpler way is, instead of you do it differently like this, and you do separate the work in this way, you just give the absolute value on this f of x minus g of x, and then just integrate from a to b at once to get what you like to have, the area A. Okay? So even though you have a very many different interval with which graph is above the others, and all you have to do is just take an absolute value to take an integral on the whole interval. It's like this. Compute the area of the region bounded by the curve y is equal to x square and y is equal to x minus 2 square from 0 to 1. As you see, those two graphs can be drawn in this way. So what you are looking for is this area A1 and this area A2. You have to add those two areas. So in order to find those, all you have to do is just to take absolute value of x minus 2 square minus x square, and then take an integral from 0 to 2 dx. So you can find the answer like this. This can be done in here. Copy. And you do practice in here. Okay, here, the absolute value of f minus g integrated from 0 to 2. That's what you like to have. And which is 4 that you have seen in here. So that's the fact. So this is what you did by hand, and this is what you got with the sage. So if those agrees, then you can make sure those works. Then you may change the functions like this, and you may do integrate from. You can do the other problems in a way. And you can do practice it with the same command for other problems. Okay. Anyway, yeah. But but in that process, you may recognize that these regions are, after you just draw the graph, you can easily figure out these regions are just, it's very symmetry. So you may just find the integral from 1 to 2, and of this, you may just find the one area and just multiply 2 to get the whole areas. And that's the, so if you know the graph, then you don't have to do the computation twice, and you may just use those properties to get the answer that you like to have. Okay. And also, we have done the integration with respect to the x-axis, but the same thing can be done on y-axis. So we can find the area between this x is equal to f of x and x is equal to g, x is equal to f of y and x is equal to g of y in a similar way. If you want to find this area, all you have to do is integrate f of y minus g of x from C to D. From C to D like this. Upper one minus lower graph, and from the smaller to the large like this. Okay, and this example shows what we discussed. Find the area enclosed by the parabola x is equal to y squared and the line y is equal to x minus 1. Then this is what we have. This is a line and this is a parabola, and this intersect at 2 points here and here. So what we like to have is we want to integrate. In order to find this, it's much easier to find the integration with respect to y-axis from here to here, this minus that. So integral from minus 1/2 to 1, f of y minus g of y, which is x minus 1 and y minus 1 minus 2y squared. Okay. Y plus 1, since this y is equal to x minus 1, so x is equal to y plus 1 here, and here this is x is equal to 2y squared. So just to do integration, then you get 8/9, like what you have. That also can be done in a similar way. Okay. So you do integrate it, find the 1.125, which is 9/8. Here you can, if you want to find, then what you gonna have? 9/8. So there are many ways to get the answer you like to have. And I think the last example. Here, example 5. Determine the area of the region bounded by the curves. Y is equal to 1 of x, y is equal to 1 of x like this, and y is equal to x like this, and x is equal to 2. Then we have this region. So all you have to do is just integrate this minus this from 1 to 2. So integrate x minus 1 of x from 1 to 2, which gives us this value. So all you have to do is just have a proper figure to get it. Last example shows find the area between the curves y is equal to 2x squared plus 10 plus and y is equal to 4x plus 16 between x is equal to minus 2 and y is equal to minus 5. So minus 2 to minus 5, minus 2 to minus 5, and the one graph and the second graph here. So we do draw the graph and we want to find the area. We want to find the area. So, yeah, we draw the graph, and we draw the graph from minus 2 to 5. We want to find this area. So, we just integrate 2x, we just integrate the upper graph to the lower graph to get the answer. That's what we've done on this. So whatever. For this, the finding area is all you have to do is draw the proper graph and find the intersection point. You choose whether x-axis or y-axis is which one's better, and do make a formulation of integration, and then just do computation with any possible ways to get the answers. That's what you're supposed to do. There are many problems that you already have done it, and just do some practice on those. And I will give you the chance to go through it. Okay? On section 6.1, I think that will do it. We had a wonderful cherry blossom last week. Okay, before we start 6.2, we may take some rest. Any questions?